Hello once again to all my students, viewers, and subscribers, and welcome to another episode of my lecture series in Integral Calculus. In this episode, I will discuss definite integrals and relate it to the area under a curve. In the first episode of this series, which is entitled Introduction to Integral Calculus, I have already given a preliminary discussion about definite integrals. And you may already be familiar with this illustration, as well as these mathematical expressions. Actually, this is the definition of the definite integral. On the other hand, these equations represent the second fundamental theorem of calculus, which we will use to evaluate the definite integrals. So in this video, I will go over the definition of the definite integral once again and recall the fundamental theorem which would enable us to evaluate them. I will discuss the important properties and solve several example problems to demonstrate how to evaluate definite integrals. But before I begin, I'd like to give a shout out to my students in Integral Calculus this semester. They are first year engineering students in Batangas State University, Alangilan Campus. Ito yung mga sections nila. ECE 1201, ECE 1202, 1203, 1204, 1205, and special section yung isa kasi kakaiba, MEX 1201. Ayan, yung huli, Mechatronics Engineering yung course nila. So, dun sa section na yon, yung MEX 1201, maraming Bibo kids. Hi guys, and thank you for always watching my vids and for being supportive of my YouTube career. Aral kayo ng mabuti ha, para maging mga Hokaging engineer din kayo. Okay? And now, let's go to our main business, which is the definite integral. To define the definite integral, let us consider a function f of x, which is defined on the interval a to b. Okay, so here's the graph of the function f of x. The definite integral of f of x in the interval a to b is numerically equal to the area under the graph of f of x that is bounded by the given intervals a and b. So, eto siya ngayon. Here is the area under the graph of f of x. And yung boundaries na involved is yung given interval, no? Sa left, the boundary is A, and sa right, the boundary is B. Now, to find the area of the shaded region, itong part na ito, we divide it into many rectangles. Ayan. So, kung matatandaan ninyo yung video, dun sa Introduction to Integral Calculus, ipinakita ko na ito nung dinefine ko ang definite integral. And as a matter of fact, this is just a review ng isa sa mga slides na diniscuss ko dun sa video na yon. Now, once again, to find the area of the shaded region, we will add the areas of all these rectangles. For example, this is a representative rectangle. Each rectangle here has a width that is equal to delta x. Ayan. So, we will assume that all rectangles here have equal thickness. At yung thickness nila ay delta x. And on the other hand, aside from the thickness, yung length ng bawat isang rectangle ay f of xi. Kung saan, yung f of xi, that's the value of the function. Yun yung value ng y kapag ang x ay equal sa xi. Now, the area under the curve with a and b as the boundaries equals the definite integral of the given function with limits from a to b. Diba? Nabanggit ko na kanina yan. Ulitin ko ha. Itong area na ito na gusto nating makuha, equal yan doon sa definite integral ng function na given. Kung saan ang limits na gagamitin natin is yung given interval a to b. Okay, so paano isinusulat yan? Ganito. Ito yung sinasabi kong definite integral. This is how you write the definite integral. This is the integral sign. This is the function that you want to integrate. Ang tawag dyan is integrand. Samantalang yung a at b naman ang limits of integration. Specifically, a is called the lower limit and b is called the upper limit. Okay, so this is the definite integral, and the definite integral is defined as the limit of this summation. And kung matatandaan natin, anong tawag sa summation na ito? Na ipinakita ko na dun sa video na Introduction to Integral Calculus. Anong tawag dito sa summation na to? Yes, that's right. This is called the Riemann sum. If we evaluate the limit of this Riemann sum as n approaches infinity, that would give us the definition of the definite integral. So here, ano ba yung n? N is the number of rectangles na ginamit natin. And since n approaches infinity, that means we have to divide the given area into an infinitely many rectangles. And as n approaches infinity, what would happen to delta x? Itong delta x naman na ito, mag-a-approach siya sa 0. Habang dumadami yung rectangle na ginamit natin, yung thickness ng bawat isang rectangle lumiliit. So if the number of rectangles would approach infinity, this delta x would approach 0. This delta x is equal to b minus a divided by n. Okay, and this xi here is equal to a, ito yung a, plus I times delta x. This is now again the definition of the definite integral. Although the definite integral is defined using the concept of the limit, as you can see here. However, kahit na yung definition niya ay may limit, it's inconvenient na every time mag-e-evaluate tayo ng definite integral, mag-e-evaluate din tayo ng limit. So ano ang gagamitin natin sa ating mga calculations? Every time mag-e-evaluate tayo ng definite integral. So dito ngayon papasok ang kahalagahan ng fundamental theorem of calculus. Specifically, yung pangalawa, the second fundamental theorem of calculus. Okay? If I will integrate f of x dx, so using this integral sign na walang limits, remember, yan ay indefinite integral. Yung makukuha kong sagot dito na capital letter f of x, yan yung antiderivative. Okay, which is a function. So now, what will happen if I will make this a definite integral? No? Anong mangyayari kapag ginawa ko siyang integral of f of x dx from a to b? Meron bang provision ang fundamental theorem of calculus para ito ay ating ma-evaluate? Yes. Okay, ang gagawin lang natin is, sa simula, i-disregard muna natin yung a at b. And i-assume natin na indefinite yung integral. So may makukuha tayong antiderivative. Now, after nating makuha yung antiderivative, doon natin i-apply yung limits. At ang sabi ng second fundamental theorem of calculus, para i-evaluate ang integral na ito, na may limits na a to b, kinakailangan i-evaluate mo yung antiderivative. Upper limit minus the lower limit. So ito ngayon ang central statement ng second fundamental theorem of calculus. And this is what would enable us to evaluate definite integrals. Again, para makapag-evaluate tayo ng definite integral, gagamitin natin ang fundamental theorem of calculus na nagsasabi na sa simula, kukunin muna natin yung antiderivative. Pag nakuha yung antiderivative, i-evaluate ang antiderivative f of b, which is the upper limit, and then maminusan mo ng f of a, which is the lower limit. Okay, so again, tatandaang mabuti, in evaluating a definite integral, it's always the upper limit minus the lower limit. Now, itong definite integral na ito, hindi siya nakadepende sa x. Why? Because actually, itong x na ito, pwede kong palitan. Pwede ko siyang gawing f of t dt. But still, yung makukuha kong sagot, hindi magbabago. Now, unlike when we evaluate the indefinite integral, ang nakukuha natin kasi dito function. But when we evaluate a definite integral, what we get is a number. no? May nakukuha tayong numerical value. So, tatandaang mabuti ha, the definite integral of a function is a number and it does not depend on the variable x. Why? Because even this x can be replaced with any other variables and still the answer would be the same. So, saan lang pala nakadepende itong definite integral? Nakadepende lang siya dun sa values ng lower at upper limit. Naiintindihan po ba? Now, before we solve example problems, let's take a look at the important properties of the definite integral. Ano ba yung mga properties nila which are worth knowing? Unang property, sanay kasi tayo, halimbawa, binigyan ka ng function integral of f of x dx from a to b. Now, what if yung lower limit at yung upper limit ay naging magkagaya? If we will apply the second fundamental theorem of calculus, madali lang yan. Diba? Sabi upper limit, so this will be equal to f of a minus yung lower limit na f of a din. Ay malamang, sigurado, yung value ng f of a dito at yung value ng f of a dito parehas. At pag silang dalawa ay ating pinag-minus, ang makukuha nating sagot definitely ay 0. Okay? So this is the first property of definite integrals. Kapag ka nag-evaluate tayo ng isang definite integral na ang limits ay parehas, the lower and the upper limits are the same, the answer is automatically 0. Hindi na kukumputin yan. Pag nakita mong ganyan siya, matik, 0 na yan. Next property. What if, again, ito ha, dyan tayo sanay, integral ng f of x dx from a to b. What if ginawa kong baliktad din yung limits? What if binaliktad ko yung limits? Instead of from a to b, ginawa ko siyang from b to a. Ano kaya ang makukuha ko? Ang ginawa ko lang dito is from the usual na sanay ka, a to b, ginawa mo siyang b to a. O, edi applyan mo ng second fundamental theorem of calculus. Magiging f of a ito minus f of b, which is kabaliktaran lang nung usual na ginagawa na f of b minus f of a, di ba? Negative niya lang. Therefore, this must be equal to the negative of the integral of f of x dx from a to b. Okay, so that's the second property. No? Interchanging the limits would give us the negative of the original. Kung ito yung original at pinagpalit natin or in-interchange natin yung limits, ang makukuha nating sagot is negative of the original. Next property. What if may constant? Tapos may multiplier na function. Okay, so if you recall the property of the indefinite integral, sa indefinite integral ito ay ating nilalabas. Right? So, ganun din dito, pwede mo rin siyang ilabas. So, this will be equal to c times sa integral from a to b of the same function f of x dx. Now, what if we are integrating a sum of two or more functions? Kagaya nito. Ayan no. Here, we integrate the sum of f of x and g of x from a to b. So again, there is a similar property for indefinite integrals, no, na ginagamit natin. Pwede natin silang i-integrate individually. So this is equal to the integral of f of x dx from a to b plus minus the integral of g of x dx from a to b. Okay? And kung natatandaan ninyo, itong dalawang ito ang tinatawag natin na ano? Kung natatandaan ninyo, may tawag tayo dyan. Do you recall? Yes, ang tawag dyan ay ang linearity property. Why? Because integration is a linear operation. That's why applicable ang linearity property. We know that this area under the graph of f of x from a to b can be found by evaluating the definite integral of this function f of x with limits from a to b, right? Now, if I will put a constant here in between a and b, another constant, c for example, then the original area will be divided into two regions. Here, we will have an area on the left side and another area on the right side. But if we add these two areas, the answer would still be the same. Kagaya pa rin yan ng original area na nakuha natin kanina. na equal dun sa integral ng f of x dx from a to b. Now, this would lead us to another important property of the definite integral. So, remember, yung buong area na shaded dito, yung kulay blue, equal siya sa definite integral ng f of x from a to b. Nung naglagay tayo ng constant dito, nahati yung area into two regions. Mathematically, I can integrate f of x from a to c. Diba? At ang makukuha ko doon is area 1. Okay? From A to C yun. Yan yung area under f of x from A to C. Right? At pag in-integrate ko naman itong f of x from C to B, yung makukuha ko is yung area sa right region, A2. So that means if I add these two areas, that would still be equal to the original area na ang integral expression ay ito. That is why I can write this expression as a sum of two integrals. Yung definite integral from A to C at yung definite integral from C to B. Okay? So, tandaan natin ha. Bakit? Kasi nga itong integral na ito of f of x from A to B is the area under f of x from A to B. Nung nagkaroon tayo ng constant na C, nahati yung buong area into two separate regions, area 1 at saka area 2. But mathematically, this area 1 equals the integral of f of x from A to C. And this area 2 equals the integral of f of x, this time from C to B. Okay, so this is another important property of the definite integral. So once again, we should always remember that the definite integral can always be related to the concept of the area. So now, what if yung f of x, ang graph ng function sa interval na a to b ay nasa ibabaw ng x-axis? Ayan o. If f of x is greater than or equal to 0 for all x's in the interval a to b. Ano ang ibig sabihin yan? Kung ang graph ng f of x ay nasa ibabaw ng x-axis, natural, yung area na makukuha ko nasa ibabaw din ng x-axis. Right? And because of that, yung area na yon may positive na numerical value. Okay? Yung makukuha nating area, which is this definite integral, is greater than or equal to 0. Now, what if magkaroon naman tayo ng f of x, tapos yung kanyang graph, halimbawa, lagay natin dito, what if f of x is less than or equal to 0? Okay? For all x in the interval a to b. What will happen? Ang ibig lang sabihin niyan, yung graph ng f of x ay nasa ilalim ng x-axis. So dahil dyan yung area, nasa ilalim din ng x-axis. At ang makukuha nating area, it must be less than 0. So therefore, the definite integral of f of x dx from A to B would be less than or equal to 0. Okay? So dito ngayon tayo magkakaroon ng concept ng positive area at saka negative area. Kapag ang area ay nasa ibabaw ng x-axis, positive yon. At kapag ang area ay nasa ilalim ng x-axis, ang makukuha nating area ay negative. So tatandaang mabuti. Next, what if magkaroon naman tayo ng function na ang graph, may part ng function nasa ibabaw ng x-axis at may part ng function ang graph naman ay nasa ilalim ng x-axis. Kagaya nito, halimbawa, ayan. So, gumawa ako ng isang function dito, nakitang-kita natin, may part ng function ang graph niya nasa ibabaw ng x-axis. Ito yun, no? Ang interval natin from negative 2 to 0, 2. So, ito ay 1. So, here, x is equal to negative 2. Here, x equals 1. And here, x equals 3. Para bagang kanina, ito yung A, ito yung C, at ito yung B. Now, ano kaya ang makukuha nating area dito? Kapag nakita natin na yung function ay may part na nasa ibabaw at may part na nasa ilalim, ang makukuha nating area ay net na area. I-add mo yung dalawa, positive at saka negative. So kung sino ang mas malaki, siya ang magwawagi. So for area 1, ito yon, area 1, that is the integral of course, the given function. Kung ano man yung equation niya, f of x na lang siya. So this area 1 is equal to the integral of the function from Okay, this is the lower limit from -2 to 1. And we are sure na ang makukuha natin ditong area ay ano? Positive ito. This is a positive area because it's above the x-axis. And for the second area, itong nasa ilalim ng x-axis, let's label it as A2. Area 2, that is the integral of f of x dx, this time from, ang lower limit niya ay 1 hanggang 3. And obviously, since nasa ilalim siya ng x-axis, ang makukuha nating numerical value dito, ang sign ay negative. So, for the second area, we will have a negative area because it's below the x-axis. Now, what if i-integrate ko yung f of x mula -2 hanggang 3? Isang integration lang. Hindi ko siya i-integrate separately. What will I get? I will get the net area. Now, ito kayang area na makukuha ko dito ay positive or negative? So, sabi ko kanina, ang makukuhang area is yung net na area, which is makukuha natin pag inad natin yung dalawang to. So, kung alin man sa kanila ang mas malaki, yun ang magwawagi. In this illustration, mas malaki yung area sa ibabaw kumpara dun sa area sa ilalim. So, kung itong area na ito ay negative, magsusubtract siya mula sa area na nasa ibabaw. Kaya ang makukuha natin dyan is positive pa rin. So, we will get here an answer that is greater than 0. So, meaning, positive ang makukuha nating sagot. Bakit? Yung absolute value ng area 1 ay mas malaki kumpara sa absolute value ng area 2. Kaya ang makukuha nating net area dito, positive. Para bagang ganito yan. Halimbawa, ito positive 5, tapos ito negative 2. Pag inad ko yung dalawa, 5 plus negative 2, effectively, ang sagot ko, positive pa rin. Kasi nga, mas malaki yung magnitude ng 5 kaysa sa 2. Diba? Okay, so ganun lang kasimple. Now, what if I want to get the total area that is bounded by f of x and the x-axis? Yan. Gusto kong malaman yung total area that is bounded by f of x and the x-axis. Pauwiin ko muna to. Ano kaya ang aking gagawin? Kung gusto mong malaman yung total area, edi dapat i-add mo yung A1 at saka A2. Kung i-add ko sila, hindi ko pwedeng i-integrate ito. Recta from -2 to 3. Bakit? Pag in-integrate natin yan from -2 to 3, this area will be subtracted from area 1 because it's negative. So once again, if you want to get the total area that is bounded by the function f of x and the x-axis, you have to add these two areas. So what you will do is to get the two areas individually. Kunin mo muna yung area 1. That's the integral of f of x dx from -2 to 1 na positive na. Alam natin positive yan. Plus, yung pangalawa, kunan mo ng absolute value kasi alam mo na negative yung area niya, no? The absolute value of the integral of f of x dx from 1 to 3. So, bakit natin kinuna ng absolute value yung pangalawang integral? Okay, kasi alam natin na negative siya. And remember, this is not equal to the integral of f of x dx from -2 to 3. Hindi sila equal. Bakit? Kasi nga po, kapag kinuha mo yung resulta ng integral na to, ang nangyari is A1 minus A2. Kasi negative yung A2 eh. Pero kung gusto mo makuha agad yung total area, dapat i-add mo sila, hindi mo sila pagma-minus. Okay? So, anong bottom line dito? Ang bottom line dito is, kapag yung function, nakita mo na may part ng graph na nasa ibabaw at may part ng graph na nasa ilalim, kinakailangan na i-integrate mo sila separately para makuha yung total area. Otherwise, yung makukuha mong sagot is yung net area, which is yung nasa ilalim na part ay masusubtract mula dun sa part na nasa ibabaw ng x-axis. Okay? Para hindi ka magkamali, you have to integrate them separately. Now, let us solve example problems para ma-demonstrate ko sa inyo kung paano mag-solve ng mga definite integrals. Okay? Here is the first example. Evaluate the definite integral for dx from 1 to 7. So here, the given function is a constant, 4. Para baga ang nangyari, y is equal to 4. So isang horizontal line lang yan. Now, mamaya na yung graphical, i-integrate muna natin ito. Okay, paano ba mag-integrate? Sabi, i-integrate muna natin yan na di-disregard itong limits na ito. So, makakaroon tayo dito ng 4x. Tapos, yung antiderivative na yan, i-evaluate natin from 1 to 7. Okay? Using the second fundamental theorem of calculus. Na ang sabi, upper limit minus the lower limit. So, that would be 4 times. Yung x, papalitan ko lang ng 7. Minus the lower limit. Yung x, papalitan ko lang ng 1. So, ganun lang kadali. Ang makukuha kong sagot dito is 4 times 7 minus 1 is 6. So, 4 times 6 is 24. Remember that the definite integral is related to the area, right? So, pwede tayong gumamit ng graphical approach para ma-solve ang problem. I-graph lang natin yung function. Diba, remember, itong y is equal to 4 is just a horizontal line. Okay? At kukunin natin yung area sa ilalim ng horizontal line from 1 to 7. So, ito na siya ngayon. Okay? Ito yung graph ng y is equal to 4. At kukunin mo yung area from 1 to 7. Ito yung lower limit at ito yung upper limit. So, in effect, meron tayong isang rectangle. At yung rectangle na yan, alam naman natin ang formula sa pagkukumpute ng area niya. Diba? Its area is simply equal to its length multiplied by its width. Ano ba ang length ng rectangle na to? So, its length from 1 to 7 is 6. And its width is from 0 to 4, that's 4. And 6 times 4 is 24. That's it. Ayan parehas lang yung sagot. 'Di ba? Kasi nga po, ang definite integral ay ang area under the graph of a function. So, ano ang natutunan natin dito? Na-realize natin na posible pala na makuha ang sagot sa definite integral kahit hindi mo i-evaluate ang integral. Yes, bakit? Kasi nga, kung hindi mo ma-evaluate yung integral, pwede mo siyang isolve using the graphical approach. Kasi parehas lang ang sagot na makukuha mo. So, in case, maka-encounter ka ng problem na hindi mo ma-integrate yung given. Bakit? Kasi hindi mo alam kung paano i-integrate. Ang gawin mo is yung graphical approach. Baka posible na yung function, pag i-graph mo, merong available or known formula in geometry sa pagko-compute ng area niya. So, ang gagawin mo is, gamitin mo yung known formula in geometry para makompute yung area. At yung makukompute mong area na yon, yun din yung sagot dun sa definite integral na hindi mo ma-evaluate. Next example. Evaluate the definite integral x squared minus 1 from 0 to 2. So, gamitin muna natin yung conventional na solution. Mag-i-integrate tayo. I-integrate natin sila term by term kasi yan naman ay readily integrable. This will become x cubed over 3 minus x. Yan yung antiderivative. At yung antiderivative, evaluate natin from 0 to 2. Now, in evaluating the antiderivative, laging upper minus lower limit. So, gawin muna natin yung upper limit. Ano ang upper limit niya? So, 2 cube is equal to 8. So, makakaroon ako dito ng 8 over 3 minus x na gagawin kong 2. Minus, ang lower limit ko ay 0. So, itong dalawang to, pag pinalitan ko ng 0, ang sagot 0 lang din. So, makukuha na natin ngayon yung sagot sa definite integral. Kapag ito ay ating sinimplify, ang common denominator ay 3. Kopyahin ko lang yung 8, tapos ito gawin kong 6. So, ang sagot, 8 minus 6 is 2. So, ang sagot, 2/3. Diba? Ganun lang kadali. Sobrang dali. Hindi mo kailangan ng calcu. Okay? Mental math is enough. Now, anong graphical approach niyan? Kung gusto mo yung graphical approach, ay di-imaginein mo, ano ba to? Anong klaseng function yan? Quadratic function yan, di ba? Kung yan ay y is equal to x squared, di ba yan ay parabola, opening upward, na ang vertex ay nasa origin. Halimbawa, ito yung parabola. Ayan. Ang sabi, yung y ay naging x squared minus 1. So, ano mangyayari sa graph niya? Kung x squared minus 1, di yung graph matatranslate ng 1 unit pababa. Kasi minusan mo ng 1. So, ang mangyayari sa kanya, ito na ngayon yung graph niya. Bababa siya ng 1 unit. Tapos, ang hinahanap natin is yung area from 0 to 2. Ito yun, kasi 0. Tapos, kung nasaan man yung 2 dyan. Now, bigyan na lang kita ng mas accurate na drawing. Ito siya. Ayan. So, ito yung vertex ng parabola. Opening upward siya. Gusto nating malaman yung area from 0 to 2. So, kitang-kita natin may part ng area na nasa ilalim, itong area 1, negative yan, at itong area 2 ay positive. So, nung in-integrate natin yung expression na ito, yung 2/3 na yan, di ba, nakuha natin sagot 2/3, that is equal to area 1 plus area 2. Yung area 1, negative, at yung area 2, positive. Nagkataon lang, mas malaki yung area 2 kumpara sa area 1, kaya yung net na area na nakuha natin ay positive. Nakakaintindihan po ba? Okay, so madali lang yan. Next example. Evaluate the definite integral square root of 3x minus 2. So it's also possible na kapag nag-evaluate ka ng definite integral, hindi agad readily integrable yung given. So, kung hindi siya readily integrable, perhaps you can use substitution method, right? Ano ang gagawin nating u? Obviously, yung nasa loob ng square root, 3x minus 2. At yung makukuha kong du ay 3 dx. Next, itong buong to, pwede ko na ngayong isulat in terms of u. Diba? So, ito yung u raised to 1/2. Tapos yung dx, ito yun. Papalitan ko ng 1/3 of du. So, 1/3 of du. However, kung yan ay in terms of u na, hindi ko pwedeng ilagay at kopyahin yung limits na 1 to 6. Why? Because these limits are for values of x. And since we used a change of variable, nag-substitution tayo, hindi natin pwedeng ilagay na yan ay 1 to 6 pa rin. Kasi nga, hindi na x yung variable. So, ang gawin mo, i-integrate mo muna yung function. Okay? Let's integrate. This will become 1/3 times, pag in-integrate natin yung u to the 1/2, di ba magiging u to the 3/2 yan. So, 2/3 u raised to 3/2. Ibalik natin sa original variable na x. So, ito ay magiging 2/9 times, ano yung u? Yung u na ginamit natin is 3x minus 2. Ayan, 3x minus 2. And then raised to 3/2. Ayan. At ito ngayon, ang i-evaluate natin from 1 to 6. Kasi x na ulit yung variable. Pwede na tayong mag-evaluate, di ba? So, pag in-evaluate natin yan, 2/9 times upper limit muna. So, 3 times 6 is 18. 18 minus 2, 16. Square root ng 16, 4. 4 cube. 4 cube is 64. Okay, so 64 minus, lower limit naman, 3 times 1, 3. 3 minus 2, 1. Square root ng 1, 1. 1 cube, 1 pa rin. So, 64 minus 1 is 63. 63/9 is 7. And 7 times 2 is 14. Shit! Nakuha na natin yung sagot. Diba? Ang dali lang. Walang kasing dali. And remember, kapag nag-evaluate ka ng definite integral, geometrically, yung nakukuha mong sagot ay ang area under the graph of the function. Sa interval na given. So, dito, ang interval ay 1 to 6 kasi ang limits ay 1 to 6. Okay? Dali lang, di ba? Next example. Evaluate the definite integral. Ayan, this time, gumamit naman tayo ng function na may sine at saka cosine. So, obviously, this is not readily integrable. So, we will use once again substitution method. So, dito, ano ang gagawin natin na u? We will let u be equal to sine x. Tapos yung du ay cosine x dx. Yan. Now, pag atin yung in-express in terms of u, this will become u squared. Ay, itong cosine x dx, yan ay magiging du na lang. Tapos, wag nating ilalagay yung limits. Again, why? Because 0 and pi over 2 corresponds to values of x. Okay? I-integrate mo na lang muna. So, magiging 1/3 of u cube. Tapos, yung u, ibalik natin sa original na variable na x. 1/3, ano yung u na ginamit natin? Sine x. So, sine cube of x. At ito ang i-evaluate natin from 0 hanggang pi over 2. So, paano mag-evaluate niyan? Madali lang. Upper limit minus the lower limit. 1/3 of sine of pi over 2 cube minus sine of 0 and then cube. Ano ba ang sine of pi over 2? Di ba madali lang? That's 1. 1 cube is still 1. And sine of 0 is 0. 0 cube is 0. Okay. So, ayan. Ang sagot natin ay 1/3. Di ba? Ang dali lang. Sobrang dali. Tingnan nga natin graphically kung ano yung itsura ng function. Ito siya, oh. Di ba? Ang ganda ng function. Kung anong itsura niya sa kaliwa, yun din yung itsura niya sa kanan. Mamaya. No, may technique akong ituturo sa inyo sa pag-evaluate ng mga ganyang klaseng functions. So, dito ang gusto lang nating malaman is yung area under the graph of the given function from 0 to pi over 2. Ito yun, no? 0 hanggang pi over 2. Di ba yung pi over 2? Ano ba yun? 3.14 yung pi, kalahati nun. So, 1.5 something. So, ayan na siya. Maliit lang yung area, kaya ang numerical value na nakuha natin ay 1/3. Diba? Okay, next example. Evaluate the definite integral of the square root of 4 minus x squared from 0 to 2. So, sa unang tingin, mukhang hindi ito readily integrable. Kaya, malamang ang una mong maiisip ay gagamit ka ng substitution. Right? Diyan ka magaling. Substitution. Ang gagamitin mong u ay 4 minus x squared. Diba? Now, ang makukuha nating du ay the negative of 2x dx. Yan. Ang problema, sa given, dx lang. At ang nakuha mong du ay x dx. Diba? Magkaiba sila. So, obviously, hindi gagana ang substitution method na ito. Para ma-solve itong integral na ito, kinakailangan mo ng special technique of integration na hindi ko pa naiituro. No? Yun yung tinatawag na trigonometric substitution. Pang finals pa natin yun. Bakit mo nga ibinigay? Hindi mo pala natuturo. Ang reason is for you to realize that there is an alternative way to get the answer to the definite integral if you don't know how to evaluate the given function. Di ba kanina, anong sinabi ko? Kung hindi mo ma-evaluate yung given function, kasi hindi mo kayang i-integrate, baka hindi mo alam kung paano mag-integrate. The alternative approach is to use the graphical method. No? I-graph mo yung function. So dito, ano ba yung given function? Here, the given function is y equals square root of 4 minus x squared. Ano ba yan? Ano ba itsura nito? May square root. Tanggalin mo yung square root, di ba? Paano matatanggal yung square root? You have to square both sides. Okay, square mo. So, magiging y squared is equal to 4 minus x squared. Na pagka tiningnan mong mabuti, shit, itong minus x squared, ililipat ko sa kabila. Magiging ano siya? Magiging x squared siya. And then plus y squared is equal to 4. Diba? Na napakamukhang familiar. Ano ito ngayon? Familiar na familiar ka dapat dyan. Itong equation na ito ay equation ng ano? Yes, this is the equation of a circle. Na ang radius ay equal sa, yes, 2. Kasi r squared yan. At ang center niya ay nasa origin. Okay? Sir, kung ito circle, ano to? Edi kalahati ng circle. Yan naman ay semi-circle. By default, kung ito ay positive, edi ang i-consider mo is yung circle sa ibabaw. Kung nagkataon negative yan, ang i-consider mo yung semicircle na nasa ilalim. So, ito na yung graph niya. Ayan. So, ang center niya nasa origin at ang radius niya ay 2. So, mula sa integral na ito, kita natin ang limits ay 0 to 2. That means ang area na gusto lang natin kuhanin is yung area under the graph of the semicircle from 0 to 2. Which is essentially quarter of a circle. Diba? Yung area na gusto nating makuha ay isang quarter circle, 1/4 ng circle. At alam naman natin ano ang formula sa pagko-compute ng area ng circle. That is just pi r squared. So kunin mo lang siya ng 1/4 kasi quarter circle yan, diba? So 1/4 of pi times 2 squared. Okay, so 2 squared is 4, 4 over 4 is 1. So, ang matitira ay pi. So, that means, meron na tayong sagot. Pwede mong malaman ang sagot sa integral na ito kahit hindi mo i-evaluate yung integral actually. Yun palang integral of the square root of 4 minus x squared dx from 0 to 2, ang sagot pala dyan ay pi. Diba? So, tingnan ninyo yung aking given Parang algebraic siya eh, no? Pero ang sagot niya naging pi. Paano nangyari yun? Sabi ko nga sa inyo kanina, para yan ay ma-integrate mo, gagamit ka ng trigonometric substitution. And applying trigonometric substitution, there is a possibility. Kasi trigonometry yun eh, na makakuha ka ng sagot na pi. Okay? So that will be one of our topics in our finals. Okay? Now, let us have another example. Evaluate the definite integral x dx over the square root of x squared minus 15 from 4 to 8. So again, your first instinct here would be to use substitution. And we will let u be equal to x squared minus 15. And du will be 2x dx. So now I can write the given integral in terms of u alone. This x dx will be replaced with 1/2 of du. 1/2 of du. Tapos ito, u raised to negative 1/2. Kasi po nasa ilalim yung square root. So pag iniangat ko, magiging negative siya. 'Di ba? So pag inintegrate natin yan, ang sagot is 1/2 times u to the negative 1/2. Negative 1/2 plus 1 is 1/2. Okay, so u to the 1/2. Tapos may multiplier pa na 2. 2 times u to the 1/2. So dito makakancel yung 2. At ibalik natin yan sa original variable na x. So here, we will get u to the 1/2. Or square root of, ano ba yung u natin? X squared minus 15. At ito ang evaluate natin from 4 to 8. Now, to evaluate this, upper limit minus lower limit, ito papalitan ko ng 8. 8 squared, 8 times 8, 64. 64 minus 15, 49. Square root of 49 is 7. Minus 4 naman. 4 squared, 16 minus 15, 1. Square root of 1, 1. Okay, so 7 minus 1, that's 6. That's it. Tapos na yung laban. Meron na tayong final answer. Ang integral na ito, pag in-evaluate natin, ang sagot ay 6. Now, tingnan natin graphically. Ano kaya itsura ng area nito? Diba? Na eksaktong 6. So ito yung f of x mo. Ayan, ito yung f of x. At kinuha natin yung area sa ilalim ng f of x from 4 to 8. And that area is exactly 6 units. Now, kung yan ay binigay sa'yo na drawing, mahirap kuhanin yung area. Bakit? Kasi irregularly shaped yung area. Wala naman tayong formula ng area para sa ganyang shape. 'Di ba? Kaya dito, mas practical na tayo ay mag-integrate. 'Di ba? To get the area. Pero kanina, hindi mo alam kung paano mag-integrate. Kaya ang ginamit mo yung formula na alam mo sa geometry. 'Di ba? Ang galing. Amazing grace. Okay, let us solve another example. Evaluate the definite integral x cubed minus 4x from negative 2 to 2. Okay, so dito pansinin natin na yung limits natin ay parehas ang magnitude. Yung isa lang ay negative at yung isa naman ay positive. Okay? So ano kaya ang mangyayari kapag in-evaluate natin ang ganitong integral? So is this readily integrable? Yes. Okay, integrating the two terms individually, we will get x to the 4th over 4 minus 4x squared over 2 is just 2x squared. Tapos yan ay evaluate natin from negative 2 hanggang 2. Now, ano kaya ang makukuha nating sagot? Yung 2 to the 4th ay 16. 16 over 4 is 4. Okay, so we have 4 minus, so this is 2 times 2 squared is 4. So 2 times 4 is 8. Okay, so we have 4 minus 8 minus, so for the lower limit, negative 2. Negative 2 to the 4th is still 16. 16 over 4 is 4 minus, eto 2 times, what is negative 2 squared? 4 pa rin. 2 times 4 is 8. So basically, pag tiningnan mo yan, parehas. Ito at ito parehas. So that will give us 0. Diba? So dito, may trick ba na kinakailangan nating matutunan? Yes. So dito, ang given function, kaya siya nag-0 ang indefinite integral ay isang add function. Ano ba ang ibig sabihin ng isang add function? A function is add if it satisfies this condition. Kapag yung f of negative x ay equal sa f of x na ginawa mong negative. Anong ibig sabihin nito? Yung negative x, yan yung right side mo. So, nasa kaliwa ng iyong y-axis. So, halimbawa, gawa tayo. Yung graph na nasa kaliwa, dito, yun yung f of negative x. At yung f of x, yun yung nasa kanan. So, sinasabi nito na kung ano yung nasa kaliwa, no, negative niya yung nasa kanan. So pag tiningnan mo ang graph niyan, magkamukha yung graph. Kaso nga lang yung isa negative at yung isa positive, 'di ba? So kung magkamukha yung graph, yung area nila parehas. Pero kung yung isa positive at yung isa negative, pag inad mo yun, natural magsisiro yun. Kasi magka-cancel silang dalawa. That is the reason why ang nakuha nating definite integral ay 0. Again, that is the rule for odd functions. Okay, so bago tayo pumunta dun sa rule, i-prove muna natin na ito ay isang odd function. So, ang given f of x is x cubed minus 4x. Kunin natin yung f of negative x. Okay, so ang ibig sabihin lang ng f of negative x, lahat ng x gagawin mo lang negative x. So, negative x, saka ko i-cube. Minus 4, and then yung x, papalitan ko ng negative x. Pag in-evaluate natin yan, ang makuha natin is, ano bang negative x cube? Eh di negative x cube. Diba? Tapos ito, minus minus plus 4x. Ayan. So itong negative x cube plus 4x, kabaliktaran lang nito. Ayun, nagpalit lang sila ng sign. So this is the negative of the original f of x. Ayun, na-satisfy natin, no? Sabi natin f of negative x is equal to the negative of f of x. Therefore, the function is odd. F of x is odd. No? And what's the rule? Kapag nag-i-integrate ka ng isang odd function f of an odd function o dx from negative a to a, kahit pa anong value ng a, basta sila ay magkagaya, yung isa negative, yung isa positive, matik na yan, hindi na ini-evaluate yan. Dapat alam mo na ang sagot dyan ay 0. Yun ay property niya. Bakit po? Kasi nga, kung i-relate natin yan sa area, ang isang odd function, yung area niya symmetrical. Kaso nga lang yung isa nasa ilalim, yung isa nasa ibabaw. At yun ay magkasing laki. So yung isa positive, yung isa negative, pag inad mo yung dalawa at magkasing laki sila, magsisiro talaga yon. So para mas malinaw, ipakita ko sa inyo sa next slide yung graph ng given function na ito. Ito yung graph niya. Ayan. So kita natin, meron tayong part ng graph na nasa taas. Ito yung f of negative x. At negative niya, which is ito yon, yung f of x. Kita natin na itong dalawang area ito ay symmetrical with respect to the origin. At silang dalawa magkaparehas ang area. Yung isa lang ay positive, yung isa negative. Kaya pag inad mo yan, dalawang yan. Kasi yung limits natin is from negative 2 to 2. Natural silang dalawa ay makakancel. Kaya ang makukuha nating sagot ay 0. Okay? Recall nga natin, ano ang katangian ng isang odd function? Ang isang odd function ay ganito ang property. Yung f of negative x ay negative ng f of x. Tandaang mabuti. Now, if the function is odd, ano nga ang rule pag nag-i-integrate? The integral of an odd function from negative a to a, again, kahit anong values ng a, basta negative yung isa, positive yung isa, ay laging 0. Tatanda ang mabuti. Now, ano ang mga halimbawa ng mga odd functions? Examples. Y is equal to sin x. No? Sin is an odd function. Bakit? Kasi pag tinignan mo yung graph niya, di ba ganito yun? Ayan, ganyan siya. Tapos ito, ayun. Diba? So, ito negative noon. Ito positive. Ito naman nag-negative, di ba? Ayan. So, isa pang halimbawa niyan is yung power function x raised to n. Given that n is odd, anong ibig kong sabihin? Halimbawa, when n is 1, 3, or 5, kapag ka ang isang power function kagaya nito, x raised to n, ay add ang exponent, then that function is also an odd function. Okay? Now, let us solve another example problem. Evaluate the definite integral 2 cosine 3x plus x squared. This time, ay, same na naman yung limits. Negative 1 to 1. Okay, so paano natin ito integrate? I-integrate muna natin yan gamit yung conventional integration na alam natin. 'Di ba? So, pag ito in-integrate natin, integral ng cosine is sine. Positive yan. So, magiging 2/3 sine of 3x plus 1/3 x cubed. At i-evaluate natin yan from negative 1 to 1. This will be 2/3 times sine of, okay, yung x papalitan ko ng 1, so magiging sine of 3 plus 1 cube is 1, so 1/3 na lang siya. Okay, so yan yung una nating term. Next, minus, lower limit naman, 2/3 times sine of, yung x gagawin kong negative 1. So, magiging sine of negative 3. Diba? Tapos ito, negative 1 cube is negative 1. So, magiging plus negative 1/3. So, ano ba yung sine of negative 3? Ito kasi okay na eh. Weighting na lang yan. Ito, simplify natin. Because sine is an odd function, diba? Sine is an odd function. Therefore, sine of negative x is equal to the negative of sin x. So, i-apply natin dito yan. Kopyahin ko lang to ha. Magiging ano siya? 2/3 sine of 3 plus 1/3 minus 2/3. Okay. Sine of negative 3 is equal to the negative sine of 3. Tapos ito minus 1/3. Okay. So, kung mapapansin mo, parehas sila. Ayan, no? 2/3 sine 3. Pero ito, 2/3 sine 3. Negative lang. Di ba? Ito, 1/3. Ito, negative 1/3. Pero ito, minus. So, minus, minus, magiging plus. Minus, minus, magiging plus. So, in effect, kahit tanggalin mo na to, ito na lang ang sagot. Multiply mo na lang siya ng 2. Di ba? Para bagang ganun ang nangyari? Yes, actually, ganun talaga ang nangyari. Kung gusto mong tanggalin na lang ito, di, in effect, gawin mong 0 ang lower limit. 'Di ba? So, ang nangyari pala, ito palang integral from negative 1 to 1 of 2 cosine 3x plus x squared dx ay equal lang din sa 2 times yung integral niya from 0 na lang hanggang 1 nung same function. 2 cosine 3x plus x squared dx. Bakit? Kasi kita natin sa example na to eh. Ayan no, kapag itong buong to in-evaluate mo, it's as if itong unang term ay minultiply mo lang ng 2. So ang gawin mo, yung una na lang term, no? Itong unang term na ito, yan yung integral from 0 to 1, no? Sir, paano mo nalaman na 0? Kasi nga itong term na to, kailangan mag-0 siya. Kasi gusto nating tanggalin, 'di ba? So kaya ang ginawa natin is yung lower limit ginawa nating 0. Sir, meron bang trick para dyan? Actually, yes, meron. Dito kasi sa example na to, ang ating in-integrate ay isang even function. Ayan, even function. Sir, ano naman ang meron sa isang even function? Sa isang even function, yung f of negative x ay equal sa original function f of x. Anong ibig ko sabihin? Ibig sabihin yan, kung ano ang nasa kaliwa, exactly yun din ang nasa kanan. So, pakita ko sa inyo yung graph ng function na to. I-graph natin to ha. Okay, ito yung graph niya. Ayan. So, ang ganda ng itsura ng graph, no? Ito siya. So, kung mapapansin natin kung anong itsura ng graph sa kaliwa, ito siya. Exactly, yun din yung graph na nasa kanan. Meaning, symmetric yung graph with respect to y-axis. Lagay natin dito ha. Symmetric with respect to y-axis. Kapag ganyan yung graph, then that function must be an even function. Okay, so ano ang rule? Ang rule is, if you are integrating an even function, f(e) of x dx, na ang limits ay parehas, pero yung isa positive, yung isa negative, ang gawin mo na lang, i-integrate mo na lang yung function from 0 to a. At i-multiply mo ng 2 para hindi ka mahirapan. Diba? Bakit? Kasi po, kung ano yung area na nasa kaliwa, yun din yung area na nasa kanan. Kasi nga symmetric siya with respect to y-axis. O ang gagawin mo, kunin mo na lang yung area na to. Yung area na nasa kanan. Ito yon, from 0 to a. Tapos, i-multiply mo ng 2. Bakit? Kasi yung area na nasa kaliwa, equal lang din dun sa area na nasa kanan. Okay? Di ba madali lang? Now, palabasin natin na yung given function ay even. 2 cosine 3x plus x squared. Lagay natin dito ha. Okay, the given function is 2 cosine 3x plus x squared. Kunin natin yung f of negative x. Ano ang f of negative x? So, magiging 2 cosine of, yung 3x magiging negative 3x. Plus, ito naman ay magiging negative x squared. Okay, what is cosine of negative 3x? Lagay natin dito. Cosine of negative x is equal to cosine x. Why? Because cos x is an even function. Tandaan, ang cosine x ay even. Tapos yung namang sine kanina, siya ay add. Okay? So, gamitin natin yung property. Itong cosine of negative 3x, dapat equal lang din yan sa cosine of 3x. Bakit? Because cosine of negative x is the same as cosine of x. Bakit? Kasi cosine x, again, is an even function. Tapos yung negative x, pag in-square ko, ang sagot, x squared pa rin. Ayun, no? Kung ano yung original na f of x, yun din yung nakuha nating f of negative x. So, if that is true, then the function must be even. F of x is even, and therefore, kung even siya, ito na yung i-a-apply mo pag nag-integrate ka. No? Ng isang even function na ang limits ay parehas. Yung isa negative, yung isa ay positive. Okay? Di ba madali lang? So, sa last slide naman, ituturo ko sa inyo paano ka makakakuha ng even at saka paano ka makakakuha ng add na function. What if halimbawa, kulang ka sa oras, di ba? Hindi mo na magawa yung test na f of negative x is equal to negative f of x or f of negative x is equal to f of x. No? Ito kasi yung test para malaman kung even sa or add. Is there a way for you to know kung ang function ay even? Yes, actually. No? Meron tayong rule. Pero bago yun, lagay ko muna dito yung example. Ano nga example ng even? Ayan, y is equal to cos x. Nabigay ko na kanina. And y is equal to x raised to n, provided that n is even also. Yung power function, even siya. Kapag ang exponent niya ay even. Halimbawa, x squared, parabola yun. X to the 4th, x to the 6th. Again, a power function is even if its exponent is an even integer. Okay, and also, the cosine function is also an even function. So, tatandaan ha. Now, let's go to the rules. If we combine even and odd functions, what function do we get? Okay? So, simula addition and subtraction muna. Kapag nag-add tayo ng dalawang even, ang makukuha natin even din. Tandaan ha. Now, what if i-add ko yung dalawang add? Ano kayang makukuha ko? Add pa rin. So, the rule is, kung ano yung in-add mo or sinubtract mo, ang makukuha mo ganun din. Even plus even, even. Add plus add, add. Eh sir, paano pag magkaiba? Yung even ay in-add ko sa add na function. Yung makukuha mo ay hindi even, hindi rin add. It's neither even nor add. Tandaan, pag nag-combine ka by means of addition and subtraction ng dalawang magkaibang functions, ang makukuha mo is neither even nor add. Now, puntahan naman natin, what if tayo ay mag-multiply? No? Multiply natin ang dalawang even functions. Ano kaya ang ating makukuha? Even din. What if mag-multiply ako ng dalawang add functions? Anong makukuha ko? Even pa rin. So, ang rule, kapag multiplication is same functions or similar functions would always give you an even function. But if you multiply two different functions, yung isa even, yung isa add, natural ang makukuha mo, add na. Okay? Tandaang mabuti. And don't forget, ang cosine ay even at ang sine ay add. Tandaang mabuti, seso. Ano yung seso? Cosine is even, sine is add. You should remember these rules and properties because they would be useful in evaluating definite integrals. So in the next episode, ang ituturo ko naman sa inyo is kung paano mag-compute ng area under the graph of a function. Doon, hindi na, ang topic natin is definite integral. Ang focus na natin is pagko-compute mismo ng area. Dito kasi sa topic na to, ang focus natin is yung definite integral, nirelate lang natin siya sa area. Pero sa susunod na topic or sa susunod na video, ang main focus natin is pagko-compute mismo ng area. Okay? So, if you like this video, then don't forget to hit the like button and share it with your friends and classmates. And Thank you for watching. See you again in my next video. Bye!